Algebra 1, we're reviewing Module 2, Topic 1, which is all about slope. It's all about slope-intercept form and standard form of a line. So we're going to be doing some graphing. But let's first start off with the idea of slope. The idea of slope is calculating the steepness of a line. Try to determine if the line has more positive slope, more of a negative. Maybe it's completely zero because it's completely horizontal. It's not rising or falling. Or maybe it's a vertical line, which is not a function, and it has an undefined slope. So we're going to be using a very famous formula, y2 minus y1 over x2 minus x1, to calculate the slope given 2 points. So it says find the slope. I'm given 16, negative 10, negative 7, and 5. I have color-coded these based on the x values and the y values. And in the formula, we always start with the y's, the second one, 5 minus negative 10. And then similarly, we're doing the x's subtracted, the second one minus the first one, negative 7 minus 16. And so now we just carefully calculate each part and place it in a division fraction. So 5 minus negative 10, it's really plus 10, giving us 15. And negative 7 minus 16 is a negative value, negative 23. And because 15 and 23 do not share any factors, this fraction cannot simplify. And you always want to simplify if you can. But this is our answer, and that tells me it's more like this red line. This has more of a negative slope, meaning that to get from point to point, I could go down 15 and right 23, and that would just keep going linearly down forever and ever and ever. So let's do another one. 2 minus 8 over 18 minus 20. So 2 minus 8 will drag us into the negatives, negative 6. And 18 minus 20 is also dragging us into the negatives, negative 2. And so now we do need to always simplify. So negative 6 divided by negative 2 is positive 3. And so that means I have more of a positive slope between these 2 points. So that means for me to get to any new point, I could rise 3, run 1. Rise 3, 1, run 1. And I want you to go ahead and try the other two on your own, number 3 and number 4. And just watch out for when you get 0. If 0 is in the top of a fraction, then you are talking about 0 as an overall slope. But if you were to get 0 in the denominator, that would mean that you are talking about an undefined situation. Those points are really on top of each other. So think about that as you try those. So I mentioned a little bit about rise over run, and that's a way that we talk about slope when we're looking at it graphically. So you always want to look to see, do I think the slope is positive or negative, or one of those special cases where you get 0 in the top of a fraction, or maybe you get 0 in the denominator, and that would mean you're talking more of a vertical line, which is undefined. So we always look, just like when we read a book, we want to read it from left to right, and we want to really study the nature of how much does it rise and how much does it run, and these two values are placed in a fraction. So let's take a look at some examples. These are not your problems. Your problems are these right here, so I'm going to give you those 4 to try on your own. But let's take a look at just a few examples so that you can kind of get an understanding for it. So again, I want to look left to right, and I have 2 clearly defined points. And if you notice, it looks like it goes up 2 and over 5. Rise 2, run 5. And so that means I have a 2/5 slope there. Same thing here, starting with the left, going to the right. I notice that this one is more falling and then running to the right. So it looks like it goes down 1, 2, 3, 4, down 4. And then it runs right 1, 2, 3, 4, 5, 6, 7, 8. So that means negative 4 over 8. And that would simplify to negative 1 over 2. And if you really study the other points in between these 2 given points, it does go down 1 and over 2. Down 1 over 2. So this is a more simplified way of describing what's happening between each point. Similar in number 7, starting at the leftmost point, going down 4 over 1. So that slope is negative 4. And then another positive slope here. It looks like it's going up 2 over 4. And 2 over 4 would simplify to 1 over 2. So always pay close attention to, is the slope positive? Is it negative? And you can kind of tell that immediately as long as you're looking at it from left to right. So you can try those on your own. Let's try talking about y equals mx plus b for a moment. Find the slope of each equation. So at first, we are asking you to identify the slope and the intercept in the given form, mx plus b. Now, this is a very generous form for finding slope because it's in the problem. For example, the first one says y equals 8x plus 3. That 8x is serving as the slope value, just like that 3 is serving as the y-intercept value. So we're going to use that when we want to graph. But the first thing is you want to be able to identify those values in an equation. So I want you to try number 10 and number 11, just like I modeled in number 9, identifying the parts of the equation. You have the slope and you have the y-intercept. So what makes this slightly harder is when you have to solve for slope-intercept form. So if you notice number 13 is not really a good form for identifying slope because I don't have y by itself. So the first thing I want to do is begin getting y by itself by moving anything on that side with y to the opposite side by using these opposite operations or inverse operations. So 3y by itself, and 3 and minus 2x, those aren't like terms, so I can't actually subtract 3 minus 2x. So I want to put it in that form, or at least begin writing in that form, where I put that slope part, negative 2x, and then this constant 3 in the back. Now, negative 2 isn't quite the slope because I haven't quite divided to get y completely alone, and now I can see what my slope-intercept form would look like. And so now I can identify the slope. The slope, m, in this case, would be negative 2/3. And then my y-intercept, that's my other number, plus 1. That means my first point on the graph would be 0, 1. So you need to really solve for y in order to figure out what that slope is. So you can try that at number 12, try to get y by itself, and then identify the correct slope value and the correct y-intercept value. Now, x equals 5 is kind of a special type of problem because when we're talking about x equals 5, that means we're talking about every value of x is always 5. For example, 5, 0. Or the point above it, 5, 1, or the point above it, 5, 2, or any value below it, 5, negative 2. And so in this case, we're talking about one of those vertical lines, and in that case, we want to talk about its slope. And if I did the slope formula here, 1 minus 0 over 5 minus 5, you would notice that I have 0 in the denominator, which means for something like this, I have an undefined slope. And if you understand what a y-intercept value means, y-intercept means what point would it cross this y-axis. And if it's a vertical line that's shifted over right 5 from the origin, it's not going to have a y-intercept. So the y-intercept for this one would be none. There isn't a point where it crosses the y-axis. So we're going to talk a little bit about changing that form a little bit more. So write the following equation in slope-intercept form. I'll do 16 and 18 if you'll do 15 and 17. So I'm going to start by trying to get my y by itself by moving those terms over. And in this one, since 3 was negative, I want to add it over to be with 12. And then I want to divide any coefficient that's in front of the y value. So that gives me negative 3/4 x minus 3. This is now in slope-intercept form. My slope is negative 3/4 and my y-intercept is negative 3. I'm going to do very similar steps in number 18. I'm going to subtract 5x to the other side since it was given as a positive. Again, these are not like terms. And then since 3 is multiplying against y, I want to divide that. And you get negative 5/3 x minus 5. Again, I know the slope, negative 5/3, and I have the y-intercept, negative 5. So let's try to build the slope-intercept form by looking at a graph. And the first thing I want to do is find 2 nice points. And so we're going to start talking about graphing now. When you are looking at y equals mx plus b, the y-intercept value is this point where it crosses the y-axis. And for that one, that would be minus 4. And when I study that slope that we were talking about on a few problems ago, it looks like it's going down 2 and over 3. And so that means I would have a negative 2/3 slope. And so this would be my equation in slope-intercept form. Negative 2/3 x, that 3 is kind of hard to read, minus 4. So I want you to do the same thing with 19. Try to figure out a few good points in here. I'll kind of show you where I think those points should be. And then try to figure out what you think the slope would be and what you think the y-intercept would be. So we're going to use that same type of idea to do some more graphing. We have our y-intercept value of 4. So I'm going to start here at 4. And then my slope value is 5/3, which I really can't go up 5 and over 3 for this one. So I'm going to reverse that and go down 5, 1, 2, 3, 4, 5, and left 3. And this still creates a positive line. So just make sure you don't go down and right, because that would create a negative line. So I'm reversing up and right by going down and left. We'll try another one that's like that. My y-intercept value is 2, so that's my first point on the y-axis. And for this one, it's negative 5/3, so I want to go down 5, 1, 2, 3, 4, 5, and then right 3 to create my negative graph. So I want you to try a few of those on your own. 23 through 28, those are all slope-intercept form, or those are special cases where they are vertical or horizontal lines. So let's try some that are not in standard form, or sorry, they're in standard form and need to be changed into slope-intercept form. So I want to start by doing what we were doing a minute ago, trying to move the values away from y until I get x by itself, or y by itself. Divide negative 3 to the other side. And now I have y equals positive 8/3 x minus 3. So I'm going to start at my y-intercept value of negative 3. And now I'm going to go up 8, right 3 for my next point. And then there's my line. Okay, so finding x and y intercepts basically mean you are replacing one of the values with 0. So if I want to find the y-intercept, I need to plug in the x value as 0. So if you plug in 0, 3 times 0 is 0, and you're just left with 2y equals negative 6. I would divide the 2 to find out that the y-intercept would be at negative 3. Similarly, if I wanted to find a x-intercept, well, that means I have to make the y value 0. And if I plug in 0 for y, 2 times 0 is 0, and I'm left with 3x equals negative 6. I want to divide by 3 to find out that that is negative 2. So this is helpful if you want to graph quickly in standard form. Negative 2 for the x-intercept, negative 3 for the y-intercept, and then there's your line. So you can try your actual 34 and 35 by doing something similar, replacing all of your values with 0. Solve 2x equals 8, solve 4x equals 8, and you'll find your 2 points. Last thing, write an equation in slope-intercept form. It says you have a startup fee of $30, and you are doing a $4 monthly fee. So if I'm starting at $30, that's what I want my y-intercept to be. And if it's going up $4 every month, this is how I'm going to calculate 34, 38, 42, all of the future prices per month to join the club. So please complete your packet and give it to your teacher, and good luck on your retake. Bye.